Hello, and welcome to a brief overview of the stress component for Unreal Engine 4. In this video, we'll be going over a brief overview of the system and what you can do with it. Alright, first of all, inside the editor, once you've downloaded and enabled the plugin, make sure that you go to Content, Show Engine Content, under Viewing Options, and then Stress. So let's go down here, and then I'm already in the sections, so go to Content, View Options, Show Engine Content, and then head down over here and open the level. Once you're in here, let's go to Stress Documentation, and this shows what is exposed to the engine. So these are the component functions, stress blueprint library, interface, the delegates we have. There are two types of delegates, both multicast dynamic, which are for blueprints, as well as regular casting if you're only using it on C++, and you do not need either multi-banding and or you do not need blueprint support for them. I would fully recommend only using the C++ section. You can change that by going to your stress component settings and then change delegate use type from 1 to 2. Okay. In this blueprint, you'll also find what you can access from the structures and how you can access the structure information. Alright. Okay, so getting back to here, let's go back to framework and explain a little bit of how it works. So there are three consumption models: reducing, increasing, and build up. And so reduce will be used for something like time, health, stamina, farming resources. You name it. Increase is a model that is meant to be more for things that are usually meant to be full, and or resource available, and then get the build up towards that. Okay, there are also 4 modes of writing. So there's automatic consumption, automatic recovery, manual consumption, and manual recovery. So essentially, automatic consumption is something that is done by the system itself. So for instance, if you have something like stamina and you wanted to recover over time, this is what automatic recovery will do. Or if you want to have it to consume over time, so let's say that you enter a biohazard system or biohazard area, and it's going to constantly be depleting your health. Well, that's something like what you'd be using automatic consumption for. The stress class is divided into multiple sections, and I'll go over that in a little bit. Before, I want to go over some of the options, some of the elements, that give the system the flexibility that it has, and that is the rules for which and how it allows processes to run, and that is what overlap type is about. So essentially, it says which processes are allowed to run simultaneously. So in the previous example with health, you might want to have a health system that can have automatic and manual damage at the same time. And you might want to also be able to have an active health system, or for instance, if you're taking damage, you might also want to apply stim packages or something that increase the health over time. And I've just mentioned multiple types of resource tracking, and this is something that you can easily switch with just overlap type. However, there are some times, depending on your overlap type rules, where multiple processes cannot run simultaneously, and that is where priority set type comes in. It simply says, if we have a failed overlap type request, what do we do with it? Do we just leave it there, or do we try to stop it? And if you try to stop it, you get to priority type, which essentially says which processes are favored. Say that you have an overlap type of consume. That means that both auto consume and manual consume are allowed. And suddenly you have a manual restore request inbound. Well, by overlap, that the request will fail. However, if we have priority type set to restore, it will stop both of those processes and then begin your manual resource sections. So that is one of the ways in which you can use these rules. Okay, before we go forward, I'm going to be explaining how the system works and what are some of the elements that give the flexibility that it does. First of all, we have the stress template, and this handles name, max value, and changes, as well as the time specifiers for it. The name is particularly important because that is how we track the individual items inside stress profile and the component. So instead of tracking it by indexes, as these these indices may change over time. We use a name ID for this, so make sure that whenever you are both querying for it and or adding it, that the names are specific and constant. Then afterwards you have stress rules, which has, beyond what I mentioned of overlap and priority sections, the set of structures that the component will follow, or that your particular stress component stress layer will follow. After that, we have stress state, which essentially keeps track of what are the current activities that are active, as well as gives you the option for logging results. All of this is put together by stress layer, which also keeps track of the current state, the current decreases and increased queues. So essentially what this means is that based on a template, you see that there's a max changes, so that whenever you get manual consume request in, you can stack up the consumption itself. So even if you have like current time sections, and let's say that the time frequency for manual consumption is 0.2 seconds. So that means that every 0.2 seconds you're going to be consuming a unit, right? So what happens if you currently have a queue of 10 and you want to add more to it? Essentially just says, okay, so we currently have, let's say 8 remaining, and this request just came in with 10, so now we have 18. If your max change, let's say, is 15, that means that no matter how many times you keep requesting it, if 15 is the max, it'll stay at 15. Okay. Stress layer is then wrapped up by stress profile, which is a struct array. Well, it's a struct holding a struct array. That this is then handled and or exposed to the engine with stress component. And these functions available for stress profile, stress state, rules, and template is exposed by the class stress library. You also do additionally get a small interface with, at the moment, 3 functions, which is CI stress, and I'll be showing an example of that in the test level. In terms of technical details, each stress layer only replicates up to 17 bytes of data, so that is only the current stats and the current state. Alright, so before I continue going over the more technical sections, I'm going to go inside the engine for a little bit and go over to the example. Okay, so in this stress character, I've set up a component that is currently keeping track of five layers. So that's stamina, we have health, we have power, only tracking time, and then currently tracking increase. And here I've also included some examples of what you can do with it. So in this case, we have set our delegates. So in this case, so this delegate is going to be tracking every single change that the layer registers. Then we have something like max stress and then zero stress. So in this example, I've set up 2 handlers for zero stress. I've handled it so that when time reaches 0, it quits the game, and when health reaches 0, it prints, no, you've died. Okay. Other than that, I've also set a very quick example for damage. So in this case, whenever the actor receives damage, if we have a given class, we're going to be, using, otherwise we're going to be restoring. So far so good. And in this class, we're also going to be setting up stamina. So in this case, we're going to be jumping only if we have stamina available. And then here we're just going to be having arbitrary requests. For your project, do make sure that you replace the input elements, as these are particular to the testing project. Of course, these plugins do not allow a config engine, an engine setting file, sorry. Make sure that you do replace those. And for the purpose of this class, I've set up a UI which will be showcasing how, or the state rather, of these classes. Alright, so with that said, I'm going to be going over some of the examples, or rather the classes and the settings that you can do and what those settings mean. So let me expand this section. Alright. In template, as mentioned, you can customize name, max values, the time for cycles to happen, the time for things to wait. So in this case for stamina, the wait trigger for auto restore essentially says after consume manual has finished, how much do we wait for auto restore to potentially kick in? And then when it comes to restore cycles and consume cycles, it essentially says how often do we consume or how often do we restore. And finally, for the trigger consume is if rules have it for recover if depleted. Sorry, for is depletion disabled, is for how long do we disable the component or the layer rather. When we get down to rules, rules has a couple of settings. I've already explained the overlap type, priority type, and stress model. Some other options that you do have here are things like restore type and consumption type, sorry. And one more thing that is important to touch here is that you can control also how you want to consume your resources. So essentially, by default, no resources are consumed linearly. What that means is that the time is slightly modified depending on how close you are to either minimum stress or maximum stress. And this property here allows you to modify how much deviation you get from those settings. In terms of what is exposed to the engine from state, you can determine whether you want it to be activated by default and whether you want to lock result, and I'll show what that looks like in a second. Okay, so let's go up and test it first in single player to show the base functionality of it, and then we'll move over to multiplayer to test results. Okay, so we're going to be playing, and at the moment we have logging registered for stamina and health. So if we go back here and we try to jump and consume stamina, you'll see how the amount of consumption is currently triggered, and we're consuming 50, and now we are recovered. So as you see here, the time is slightly modified based on how close we are to full. So in this case we are restoring, but because we are relatively far from our source, instead of it taking, let's see here, 0.03, we're taking 0.034 or 0.035, and as we get closer to our maximum value, the number gets infinitesimally closer to our base element. If, however, we went over here, and let me just stop this for a second. If, however, we went over here and we added auto restore to linear, and then we went back to play, it's going to consume, and once it is consuming, you'll see that the time is stable throughout. Okay, so that's stamina sections. So based on the stacking thing, I am not going to continue to request Q consumption. As you see, it continues to stack on. I'm going to recover. So now let's go to damage. So at the moment I have died, and I'll wait for a little bit, and then it'll restore completely. So let's analyze this a little bit further. So if we go back to over here, you'll see that it triggers with time for 3.5. This is the disabled element, and then once that section's done, it says, okay, we're done, so now let's recover. So let's see that reflects it here. So we do have recover if depleted and depletion disabled, and for timers we have depletion timer for 3.5 and then 1.9, and which is what you see here. You first disable and then you go over that. Okay, alright, then if we were to test received damage, you'll see how the same 75 that we've done here instant but done over time. Sections, we test power. Right, we're going to be adding 20 units of power here. Time, and then in here we're going to check if we have enough. So ultimate go boom, and no, we don't have enough power, so let's fetch one more sections, and then ultimate go boom. All right, with that said, let's exit now and test that it works in multiplayer. So go to dedicated server and then hit play on both. Wait to join the session. Okay, so now we have here, you see that the time is updating for both, And then if we press jump, you'll see that the server is successfully the one that is registering the changes, and the client responsible for that component is also getting the changes. Same thing goes with health. Sections, portion of type. If you want to test to see the health sections, is depletion to save, recover depleted. We disable that, and then for the sake of speed, go over here and damage. Where's my damage? Okay, we go to over here. We have died. If we go, however, to our log, go down to the bottom section, you'll see that it says extreme recovery not available. So, but this standard means that you died and you can no longer get health. Alright, so let's go over to our document once again. We've covered over this. Now, in terms of integration, so in this video I've natively covered the integration for blueprints, and the same for C++. For most cases, you will not be meeting more than the component. However, if you do require that, the class has been set up for that. So if you want to use a different class to set up your timers, that is easily doable. The thing that you have to do is follow the instructions placed here. You need 4 different functions, and that'll be about it. If you have any questions, let me know. I'm available most of the week, and I'm available either through my email or my Discord. With that out of the way, I wish you a good day and have a good one.